Here we're going to graph the system of inequalities: x greater than 3, y less than 6, and 2x minus 4y greater than 10. So none of the boundaries will be included in this case, since all of the inequalities are either greater than or less than. So first of all, I've chosen the line tool. For the line x equals 3, I will enter 3, 0 as one of the points. And arbitrarily, again, another point may be 3 and 10. So there's our first line, but we want that to be a dashed line, so we click on that button, go back to the line tool. So we're going to look at points that have their x greater than 3, or so are strictly to the right of that first line. Now we're also going to look at y less than 6. And so in this case, I'm going to do 0, 6, and 10, 6. 2 points with y coordinate 6, and also change that to a dashed line. Now it's going to be points that are to the right of the first line, the vertical line, and below the horizontal line. So in the bottom right quadrant created by their intersection. Now, in order to graph the third line, I'm going to do a little bit of arithmetic with it. And first of all, I will move the 2x to the right-hand side. So 4y is greater than negative 2x plus 10. Dividing by negative 4 will give y is less than 1/2 x minus 5 halves. And so this is a line with y-intercept negative 5 halves. So 0, negative 5 halves. And I want to pick another point. And so when x equals 1, or let's let x equal 4. If x equals 4, we'd have 2 minus 5 halves, which is 2.5. So we'd have minus 1/2. So there is our third line. And again, it says y is strictly less than 1/2 x minus 5 halves. So it's everything that is below this third line, also to the right of the vertical line and below the horizontal line. So before I do the fill, let me make this third line into a dashed line. And now I can choose to fill this bottom right corner. And as a test value, let me use the value 10, 0. So 10 is greater than 3, that is true. 0 is less than 6, and 2 times 10 is 20, minus 0 is greater than 10. So our test value checks, and we are fairly confident that the shaded region is the region that we're looking for. Now, let's go down and notice that we're also asked to find the coordinates of the vertices of the solution set, and there are two of those. The one with the smaller x value is the one where x equals 3 and 2x minus 4y is equal to 10. So if x equals 3 and I substitute that into the third equation, or it's an inequality now, but I'm going to change it to an equation. I'll get 2 times 3 is 6 minus 4y equals 10. Negative 4y will equal 4, and y equals negative 1. So the x-intercept, the smaller x-intercept is, or the smaller, the vertex with the smaller x value is the ordered pair 3, negative 1. The vertex with the larger x value is when y equals 6. And again, 2x minus 4y equals 10. So 2x minus 24 equals 10. And that's going to give us 2x equals 24. Whoops, oh, I've got a 10 there. I only wrote 1. Let me rewrite that 10. And so 34 divided by 2 is 17. So the ordered pair 17, 6. And that looks appropriate on the grid. And then one last question is this region that we've shaded bounded? This time it is not, since it goes off infinitely to the bottom right.